Hello everyone, in this video I'm going to discuss an example for limits for graph sketching. A function f is given by the fx where we have the function x plus 3 over x squared minus 4. So as we can see in the function, we can simplify the situation. We can represent the situation as x plus with the 3 over bracket x minus 2 multiplied with x plus with the 2. So in two form. Kindly refers to the question A. Determine the domain of the function fx. As we can see in here, we have the constant. So if we have a constant, so the domain will be negative infinity until infinity. As for the denominator, as we can see, the quadratic x squared minus 4 cannot be equals to 0. So from here, we notice that x minus 2 cannot be equals to 0. And then we have x plus with the 2 cannot be equals to 0. So from here, the domain would be x cannot be equals to 2, x cannot be equals to negative 2. So the domain for the bottom part would be negative infinity until negative 2, union, negative 2 until 2, then from the 2 until infinity, where the 2 and negative 2 is not included. Then, for the function, we have the division. So the constant with the all real number will intersect with the domain at the bottom. So finally, our answer will be this one. So that will be the domain. For the B, find the x and y intercept for the function fx. So in order to find the x-intercept and also the y-intercept, we have to let for y-intercept when x is equals to 0. So kindly substitute the 0. So we have y is equals to 3 over negative 4. So the point will be 0, negative 3 over 4. That is what we call the y-intercept. When y is equals to 0, kindly substitute. 0 is equals to x plus with the 3 over x squared minus 4. So x plus with the 3 is equals to 0. So x is equals to negative 3. So the x-intercept will be negative 3, 0. Next is to find the C. Find the vertical asymptote and the horizontal asymptote. Same goes to the behavior for the asymptote. So by referring to the domain, notice that we have x is equals to negative 2 and also the 2 is a vertical asymptote. So we need to determine the behavior. So here we have vertical asymptote. So x is equals to negative 2 and x is equals to 2. So kindly write the situation. Limit when x approaching negative 2 from the left. Continue. We have limit when x approaching negative 2 from the right. For the function, x plus with the 3 over bracket x minus 2, x plus with the 2. Continue. We have x plus with the 3 over bracket x minus 2 multiplied with x plus with the 2. Next, kindly substitute the value x approaching negative 2. So if it refers to the number line, we have the negative 2. The value from the left approaching the negative 2, it will be negative 2.0001. As for the right, we will have negative 1.9999. By referring to the calculator, kindly substitute the situation. So for this part, it will be a positive value. If we substitute in this part, we will have the negative value. Then if for this part, we will also have a negative value. So as we can see, we have the positive over the negative, negative. Then we will have the positive infinity, which indicates that as x approaching negative 2 from the left, we will have increasing value. Or we can say the graph increasing. Continue. If we substitute negative 1.9999, we will have a positive value. If we substitute this part, we will have a negative value. And if we substitute this part, and we will have a positive value. So as we can see, positive over the negative multiplied with the positive, so we will have negative infinity. So as x approaching negative 2 from the right, the graph will be decreasing. Continue. We have the limits when x approaching 2 from the left. So we have the function x plus with the 3 over bracket x minus 2, x plus with the 2. Limit when x approaching 2 from the right, we have x plus with the 3 over bracket x minus 2, x plus with the 2. So from here, we have the value of 2. Approaching from the left, we will have 1.9999. Approaching from the right, we will have 2.0001. So if we substitute 1.999 into this part, so we will have a positive value. This one we will have a negative value. This one we will have a positive value. So finally, we will have negative infinity. So meaning that the graph will be decreasing. Continue. If we substitute 2.0001 into this part, we will have a positive. This one we will have a positive. Same goes to this part, we will have positive. So finally, the behavior will be increasing as x approaching 2 from the right. So the vertical asymptote, x is equals to negative 2 and x is equals to 2. So that will be the behavior. Next, we are going to discuss the horizontal asymptote. In order to find the horizontal asymptote, we have limit when x approaching negative infinity. So we will have x plus with the 3 over x squared minus 4. So if we substitute the negative infinity into the function, we will have the indeterminate form, which will be the infinity over infinity. So what is the solution? If we have the indeterminate form, so what we have to do is to reverse to the denominator. We have the highest denominator, which is the x squared. So what we have to do is to divide the both for the highest denominator, which will be the x squared. So as we can see in here, we have limit when x approaching negative infinity. Kindly factor out the x squared. So we will have 1 over x plus with 3 over x squared. Over, we have the x squared bracket 1 minus 4 over x squared. So if we substitute the infinity, so what we will have would be limit when x approaching negative infinity. So here we will have 1 over x plus with the 3 over x squared over, we have 1 minus 4 over x squared. So if we substitute infinity, 1 over infinity, we will have 0. 3 over infinity, we will have 0. Negative 4 over infinity, we will have 0 as well. So we will have 0. When x approaching negative infinity, the value of y will be approaching 0. Continue. Limit when x approaching positive infinity. So we will have the same thing. 1 over x plus 3 over x squared over 1 minus 4 over x squared. So finally, we will have approaching 0 as well. So as a conclusion, the horizontal asymptote will be y is equals to 0. So that is the horizontal asymptote and also the vertical asymptote and the behavior as well. Next is to sketch the graph. So kindly refers to the domain. We have the negative 2 and also the 2 as a vertical asymptote. So we have x is equals to negative 2, x is equals to 2. That will be the domain or the vertical asymptote. Next, we have the x-intercept, which is the negative 3, 0. Negative 3, 0. Continue. We have 0, negative 304, which is the y-intercept. So let's say it's over here. Continue. We have to reverse to the vertical asymptote for the negative 2. When x approaching negative 2 from the left, we will have positive infinity. So the graph will be around here, increasing. Next, when x approaching negative 2 from the right, we will have negative infinity, which means that decreasing. Continue. X approaching 2 from the left, we have negative infinity, decreasing. X approaching 2 from the right, we will have positive infinity, increasing. And then continue, we have the horizontal asymptote. So y is equals to 0. Meaning that when x approaching negative infinity, we will have either greater than 0 or less than 0. Same goes to the right hand side. We will have approaching 0, either greater than 0 or less than 0. So in order to determine which one is the situation, kindly substitute the value of x. For example, negative 100. If we substitute, very obvious, we will have the value which is less than 0. Continue. If we substitute the value of x approaching to 100, because in here they mention x is positive infinity, so we will have the value greater than 0. So finally, the graph will be something like this. So the function will be fx is equals to x plus with the 3 over x squared minus 4. So that is the situation for this case. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.